Hello friends, welcome to the series lecture of digital signal processing. Today we will discuss about design of FIR filter using window technique. Now, when I say that design of FIR filter using window technique, we will be using these windows for solving the problem. One is rectangular window, Bartlett, or it is also called as triangular window, Blackman, Hamming and Hanning window. So each of these windows will be having its own equations. So it is inevitable that you must remember the equations in examination. First one is rectangular window. So if Wn is the function of window, then its rectangular window function is going to be defined as Wn equal to 1 for n equal to 0 to m minus 1. This is very straightforward and simple equation. So here we are looking this definition in time domain, and this is a time domain equation. So we will try to multiply these hdn with respect to wn to obtain h of n. Now let me tell you the main agenda of this filter design. See, uh, the problem statement will be given in terms of Fourier series. I'm sorry, Fourier transform. That is, the problem definition will be in terms of h of e power j omega. So I need to obtain uh, impulse responses of this. So that is for the timing I'll call it as hd of e power j omega. Then I need to obtain its impulse responses, that is by taking inverse Fourier transform. Then once I obtain this will be infinite impulse responses. This will be infinite impulse responses, and I will multiply the window function Wn ranging from with m equal to these n values will be ranging from 0 to m minus 1. Okay, so that is n is equal to 0 to m minus 1. So with this, my hd of n will become, I'll call this as the hn, and this hn will be having finite impulse responses. So hence the name FIR filter. So the other windows with their respective equations are shown in the below table. That is the expression for hn or window function. So for Bartlett, it is 1 minus 2 into n minus m minus 1 by 2 whole divided by m minus 1. Similarly for Blackman and Hamming and Hanning. If you observe carefully, Hamming and Hanning, they are almost same here, because Hamming window is 0.54 minus 0.46, whereas Hanning window 0.5 minus 0.5 cos 2 pi n by m minus 1. So instead of 0.46 in Hanning window, we take 0.5 itself. So this is these the problems the examination will going to appear most of the times on Hamming or Hanning window. Or sometimes, yes, of course, you need to remember this formula to solve the examples. Now, as I told you, all these equations are in terms of time domain. When I move to the frequency domain, so I will be having rectangular window. I'll just explain with respect to rectangular window. So this is the equation in terms of time domain. When I move to the frequency domain, it will be a sinc function. This we already know, many of you. Now this is what we call it as a transition width, and this width will be equal to 4 pi m. That is what we talk about, the transition width. And the first side lobe, so when I say that this is to design, this is the first side lobe, and this stop dB, the stop band attenuation dB will be approximately at minus 13 dB. That is what we talk about peak side lobe, or the first side lobe of the frequency response. Similarly, for Bartlett window, it is 8 pi by m, and for Hanning and Hamming, again it is also 8 pi by m, and for even for Hamming also it is 8 pi by 1 m. And whereas the peak side lobe is minus 27 dB for Bartlett, minus 32 for Hanning, minus 43 Hamming. For Blackman window, the transition width will be 12 pi by m, and peak side lobe is around 58 dB, minus 58 dB. So this we'll see in one of the lecture with respect to the MATLAB program. Right now I will be concentrating on solving the example with how to design the FIR filter. Now considering directly I will move to solving the example. Now the first example, the desired frequency response of the low pass filter is, so this is the desired frequency we have. So we need to design the FIR low pass filter using Hamming window. I need to consider that m, or whatever we say n, okay, considering it to be 5. So we know that the Hamming window definition is zero point 0.5. So let me write it another way, where zero point 0.5 minus, I will multiply this 0.5 inside the bracket. So this becomes 2 pi n divided by m minus 1. So I need to calculate the Wn for this, okay, and for n equal to 0, n equal to 1, n equal to 3, and so on. Okay. So this I need to calculate and put it in one table. So that is Wn is equal to 0 0.5 minus 0 0.5 cos of 2 pi n, okay, 5 minus 1 is 4, right? So this becomes 0.5 minus 0.5 cos of 5 by 2. 2 ones are 2 twos are 5 by 2 n. Okay, so this by applying n equal to, so totally for n m equal to 5, which means that n is equal to 0, 1, 2, 3, 4. I need to calculate the values of Wn. I'll show you how to calculate the values of Wn. This is a small calculations that what we have performing. So I have Wn equal to 0.5 minus 0.5 cos n pi by 2. So that I will put it in calculator. So n I'll consider it as alpha of a in your calculator. Okay, divided by 2. So now you go to cal. It will ask for your a value. A is nothing but n here. N equal to 0 I will put. The value is Wn value is 0. Now I go press once again cal. So it will ask for a. Now I will insert 1 and this value is 0.5. Similarly cal, it will ask for a. I will put 2. It will giving me the answer 1. Similarly for 3, it is once again 0.5. The last value n equal to 4, it is giving me 0. So this is how we are supposed to calculate the value of n. Is that clear? The value of Wn with respect to Hamming window, we have calculated values for Wn. Now this is at one point. I need to the final value is to obtain Hn equal to, so Hd equal to I need to multiply with Wn to get Hn. So this point we will try to solve now. So I need to obtain Hd of n. Hd of n is nothing but an inverse Fourier transform. So that is already it is given in terms of Hd of e to the power of j omega. That is frequency response, or I say that it is a Fourier transform. Now once again we already done with the step 2. That is we have calculated the Wn values for m equal to 5. So I'll change here. This is m equal to 5. Now finally we need to multiply hd of n values with the wn value to get hn values, right? So let me solve this example here. So we know according to the given problem statement, it is hd of omega is equal to e to the power of minus j 2 omega, right? Uh, it is minus j 2 omega, where omega is running from minus pi by 4 to plus pi by 4. So since we have taken it as mod, so I just write mod less than equal to pi by 4. So this is otherwise. Now, as I told you, from this I need to obtain inverse Fourier transform. I need to apply inverse Fourier transform to obtain its impulse responses. So we know that the definition. So by definition of inverse Fourier transform, by definition of inverse Fourier transform, hd of n is equal to, what is the definition? It is 1 divided by 2 pi integration of minus pi to plus pi capital HD e to the power of j omega into e to the power of j omega n d omega. So this is the fundamental definition. So I write hd of omega as it is 1 divided by 2 pi. Our limits. So this is nothing but a frequency range. Okay. If I try to plot this, this is how it looks like, right? hd of e power j omega is going to be defined as decrement value of exponentially. Exponentially it is decaying, and I need to consider on the both the cases from minus pi by 4 to plus pi by 4. I need to obtain the samples, right? So it is nothing but I need to get the since it is a continuous signal, CT signal, I need to obtain its the impulse values at various instants of time, omega. So it is nothing but it is as good as I am trying to apply the inverse Fourier transform. This range will be from minus pi by 4 to pi by 4. What is the definition? It is e to the power of minus j 2 omega into, so that is the definition that I am trying to put it here. So that is defined by my problem statement. E to the power of j omega n, according to the definition, I keep it as it is. Now this I can rewrite the above equation as a bases are same, powers can be added, right? So therefore e to the power of j 2 omega I will take it outside, j omega I will take it outside, common factor, n minus 2 into d omega, right? Now perform the integration. So integration of this will be minus 1 by 2 pi. So integration of j omega is nothing but j omega n minus 2, but it is with respect to omega. So I should not forget to write divided by j into n minus 2. This is the integration of j e to the power of j omega n, right? If e to the power of j omega n is there, if I want to perform this integration, this is how e to the power of j omega n divided by omega n, right? Sorry, jn, it is with respect to omega that we are trying to perform the integration. Now the limits range is from minus pi by 4 to plus pi by 4. Now substitute the upper limit and lower limit in this equation. So that is hd of n is equal to 1 divided by 2 pi. So if I substitute the upper limit, it is e to the power of j, it is nothing but omega is what, pi by 4 into n minus 2. So pi by 4 into n minus 2 divided by j times into n minus 2 minus, I will apply lower limit. Lower limit is nothing but minus pi by 4. Therefore, I write it as e to the power of minus j pi by 4 n minus 2 divided by j into n minus 2. So, I can rewrite this equation as, look at this very carefully, e to the power of minus pi by 4 n minus 2 minus e to the power of minus j pi by 4 into n minus 2 whole divided by j times n minus 2. In the numerator, if you observe carefully, it is nothing but e to the power of plus j theta minus e to the power of minus j theta. So I can take this 2 inside, I'll put it inside. So therefore this becomes e to the power of j theta minus e to the power of minus j theta divided by 2j, right? So I can write this as sine theta definition, is it not? So I'll just replace this e to the power of, I take e to the power of 1 divided by n minus 2, I'll take it outside, I'll put into pi, I'll take it outside, I'll put 2 inside the bracket. Therefore this will be e to the power of j pi by 4 n minus 2 minus e to the power of minus j pi by 4 n minus 2 whole divided by 2j. Therefore this becomes n minus 2 into pi. I can replace this by sine theta. What is theta in this case? J theta. Theta is nothing but pi by 4 into n minus 2. So what is my HD of n? So finally I can write HD of n as HD of n is equal to sine of pi by 4 into n minus 2 whole divided by pi into n minus 2. So this condition is true if and only if n is not equal to 2, right? So this condition is true if and only if n is not equal to 2. What happens if n equal to 2? So put n equal to 2 here. So 2 minus 2, it becomes 0. 0 into sine 0 is 0. And denominator, put n equal to 2. 2 minus 2 is once again 0. 0 into anything is 0. So numerator is also 0. Denominator is also 0. So it will lead to indefinite form. So hence, what should I do if I want to have n equal to 2? It is very simple. You go for L'Hospital's rule. So you already know that. So whenever you come across with such condition, whenever the 0 by 0 condition appears, we should apply L'Hospital's rule. Differentiate numerator to the in the numerator itself, and differentiate denominator in the denominator independently, so that you will going to get what, when you differentiate this, you will going to get, so 1 divided by 4. This is the value that we receive when you perform numerator to numerator differentiation and denominator to denominator differentiation finally. So that is nothing but 0.25 when n equal to 2. So now once again you need to calculate for HD of n. So I should calculate HD of n from n ranging from 0 to 4, is it not? Because m equal to 5 here. So for how many values? So they have given me that n should be from n equal to 0, 1, 2 up to m equal m minus 1. What is m? M equal to 5 in our case. Therefore I need to calculate the value of HD of n from ranging from n from 0 to 4. So that is HD of 0, HD of 1, HD of 2 that I should calculate. So in this case HD of n followed by Wn. So once again h of n will be equal to the hd of n is multiplied with wn. So this, once again I'll show you with a calculator how to perform this, so that you will get to know how to calculate hd of n also. We already calculated the wn values, so that is for n equal to, for n equal to 0, 1, 2, 3, 4, right? So Wn is already calculated. So let me write this for your convenience. Wn we already calculated, and hd of n we are supposed to calculate. So for this we got the result as 0, and it is 0.5, and here it was 1, here it was 0.5, here it is 0, if you remember properly. Now we will try to calculate hd of n and we'll see what the output we'll get. Okay. For n equal to 2 it will give math error, because we are going to get sin 0 by 0, I mean 0 by 0 format. So we already calculated n equal to 2 by L'Hospital's rule, it was 0.25. Now n equal to 3, it is 0.225, and the last value cal of a equal to 4 will going to get 0.159. So these, if you observe, the values of this hd of n are symmetric in nature. Symmetric in nature. So we have calculated the value of hd of n and omega n, both the values wn. So that is here in this case, and hd of n through the derivation that what we have done, and wn, wn in this equation it is the formula of Hamming window, and finally let me multiply these two values. So it is 0 into 0.195, it is 0, and 0.225 into zero point 0.5, so this will give me a 0.115. 0.25 into 1, it is 0.25, and this is once again 0.115 and 0. Now finally we got a finite impulse responses, FIR values. The impulse responses are finite, so therefore look at this, we can make a conclusion here. So that is, the values are symmetric in nature, so therefore m is odd. M is odd because m value is 5 given, and h of n value for m is odd, and the values are symmetric in nature, right? So from this we know that how to find out the h of z. We already derived that equation h of z. Find out the values of h of z by using the equation. Okay. So once we obtain this h of n, so later on I can go for calculating the frequency component of this, that we derived from whether when h of n is symmetric and m equal to odd, we have already derived that h of z or h of omega, I call it as, so that is equal to uh, h, so that is equal to h of m minus 1 by 2 plus 2 times summation n equal to 0 to m minus 3 by 2, right, when m is odd. For m is odd, this part derivation we have seen, and you can go for the previous video to know about the derivation part of this. So this direct equation I will write cos of omega into m minus 1 minus 2n divided by 2. So this was the equation for when h of n is symmetric, h of n is symmetric and m is odd. So now m is equal to 5, right? And let me put this. So this becomes 5 minus 1 is 4 divided by 2 is h of 2 plus 2 times summation n equal to 0 to. So 5 minus 3 is 2. 2 divided by 2 is 1. Divide into h of n cos of omega m minus 1, that is 4. So 4 minus 2n divided by 2 divided by 2. So this is the standard format, and just substitute h of 2 value here. So h of 2 we received 0.25. Now write this 0.25 plus 2 into 2 into n equal to 0 cos of omega of 4 minus 2 into 0, it is 0, 4 minus 2, right, plus h of 1 cos of omega into 4 minus 2 into 1 is 2 divided by 2, right. So now this will be 0.25 plus 2 into h of 0. I'll substitute, okay, let me write it later on. So this is cos of omega 2 omega, right? Because 4 minus 2 into 0 is 0. It is 2 ones are 2 twos are 2 omega plus h of 1 into cos of, once again this is 4 minus 2 is 2, 2 by 2 is 1. So therefore cos of omega. And final, I can write this as 0.25 plus 2 into h of 0, it is 0. So this component, entire component goes to 0 plus h of 1, that is 0.115 cos of omega, right? So 2 into 0.115, perform the multiplication, we're going to get, so perform the multiplication, the final answer is 0.25 plus 2 into 0.115, we're going to get 0.23 cos omega, right? So this is my frequency component. So put omega equal to z, so this will be in terms of z transform, or so this is my finite impulse response filter, right? So another one shortcut method I would like to tell you, that is standard form. Any when we derive hd of n, so any hd of n will be in this format itself. So as we know that for this particular example, we got the answer as, so that is sine of pi by 4 into n minus 2 divided by pi into n minus 2. This was the answer that what we have received, right? So this we got it by performing inverse Fourier transform, that is nothing but by performing the integration. So if you remember this, This is entirely same that what we have done. Look at this. Sine of omega c. Omega c is nothing but a cutoff frequency. So pi by 4 was my cutoff frequency. Now n, what was m value? M value in this case was 5. 5 minus 1 is 4. 4 by 2 is 2. Right? All divided by pi into n minus m by n minus of m minus 1 by 2, which is nothing but n minus 2. So this we got, right? And again omega c divided by pi. So here omega c, what was omega? Pi by 4 divided by pi. So pi and pi get cancelled. Omega c was, this is equal to omega c was pi by 4 and pi get cancelled. So therefore it is 1 by 4 for n is not equal to m minus 1 by 2, for n is equal to m minus 1 by 2. That is 5 minus 1, 4, 4 by 2 is 2. That is equal to 2 here, and that is not equal to 2 in this case. So this is, if you remember this, that is sufficient. Put the, but you need to remember very properly. You should not commit any mistake here. So even if you remember, then every format of obtaining HD of n will be in this format. So this is on about design of FIR filter using window method. In the next video, I'll take up one more example so that you will be very much comfortable in solving this particular FIR problem. Thank you. If you have any doubts, post it in the comment box so that I can able to get back your doubt as soon as possible. Thank you.